A water heater that keeps tripping the breaker has an electrical fault, and about 9 times out of 10, that fault is a single cheap part inside the tank. The breaker itself is not broken. It is doing its one job, which is sensing too much current and cutting the power before a wire overheats or somebody gets shocked. So the thing you keep flipping back on is the messenger, not the problem. What you actually have to do is find what it is reporting, and the good part is that the fault is usually a heating element you can test in a few minutes and replace for around $20. I have gone through the manufacturer troubleshooting guides and the electrician walkthroughs so I can hand you the checks in plain language while you are standing at the panel wondering why this keeps happening. This is about an electric tank, the kind with 2 heating elements, because that is what runs on a big 240-volt breaker. A regular gas heater has no element pulling that kind of power, so it will not trip a panel breaker like this. If yours is gas and a breaker is tripping, you most likely have a power vent fan or a hybrid heat pump model, which is a different animal. Before anything else, make sure we are talking about the same switch. The breaker is in your electrical panel, and on a water heater, it is a wide double switch, usually rated 30 amps. That is different from the little red button behind the panel on the heater itself. That red button is a heat sensor, and if that is what keeps popping, you have an overheating problem, not the electrical fault we are covering here. This video is about the breaker in the panel. Sometimes one bad part trips both, but know which one you are resetting before you start chasing it. Here is the single most useful free clue, and it costs you nothing but paying attention. Pay attention to exactly when it trips. If the breaker pops the instant you flip it back on, you are looking at a dead short, which almost always means a heating element has failed inside the tank. If the breaker holds for a while and only trips after the heater has been running and making hot water, you are looking at an overload or an overheating fault instead. That timing alone points you at the right suspect before you ever pick up a tool, so keep it in mind as we go down the list. One safety rule before you touch anything. Switch that breaker fully off and confirm the power is dead with a multimeter or a non-contact tester before you remove a single cover. This is 240 volts and it can kill you. Every test below is done with the power off. Let us start with the part that causes most of these, the heating element. An electric tank has 2 of them, metal rods that screw into the side of the tank and sit down in the water. Inside each rod is a coil that glows hot, packed in insulating powder. Over the years, that rod can crack, usually from age or from sitting buried in sediment and overheating. Once it cracks, water seeps inside and touches the live coil, and now electricity has a straight path into the tank and out to ground. The breaker sees that surge and trips, usually the moment you reset it. Testing an element is genuinely easy, and you only need a cheap multimeter. With the power off, pull the access panel, fold the insulation back, and lift the plastic safety cover so you can see the 2 screws on the face of the element. Set the meter to ohms. First, the ground test, which is the one that finds a tripping element. Put one probe on a terminal screw and the other probe on bare metal of the tank. A healthy element reads nothing at all, an open line, infinity. If you get any number there, even a small one, the element is shorted to the tank, and that is your tripping fault. Replace that element and the tripping stops. While you are there, touch the 2 terminal screws with both probes. A good element reads somewhere around 10 to 16 ohms. A reading of 0 means a dead short, and a reading of infinity across the terminals means the element is burned open. Do both elements, top and bottom, because either one can be the bad guy. Replacing the element is a real do-it-yourself job if you are comfortable. You cut the water supply, drain the tank down below the element, and unscrew the old one with an element socket, which is a cheap wrench made for exactly this and runs about $10. Some elements unbolt with 4 screws instead. You set a fresh gasket, thread the new element in, and refill. The one rule you cannot break is this. The element has to be completely underwater before you turn the power back on. Run a hot tap until water flows steady with no sputtering air first. An element switched on dry burns out in seconds, and then you are right back where you started. If both elements test clean, move to the thermostat, which is the next most common cause and the usual reason a breaker trips after running rather than instantly. Each element has a thermostat clipped against the tank wall, and the upper one also works as a traffic cop. By design, only one element runs at a time. If that upper thermostat fails and sticks closed, it lets both elements fire at once, and two elements pulling together draw far more current than the circuit is rated for. The breaker trips on the overload normally after the heater has been working for a bit. A thermostat can also short out on its own and trip instantly. Test it the same way with the meter on continuity and check it for a short to the tank just like the element. Look it over for scorch marks or melted plastic too. A new thermostat is about $20 and clips in the same spot, and the trick is to move the wires over one at a time so you do not mix them up. Next suspect is sediment, and this one is sneaky because it does its damage slowly. Minerals settle to the bottom of the tank and bury the lower element like a blanket. That blanket traps heat against the element so it runs hotter and longer trying to push warmth through the crust. Eventually, it overheats enough to trip, or it cracks the element and turns into the short we already talked about. The tells are an older tank that has never been flushed, popping or rumbling sounds, and trips that happen after a long hot water demand. Draining a few gallons from the valve at the bottom and seeing sand and grit come out confirms it. Flushing the tank is the fix, and doing it once a year keeps it from coming back. Now the wiring, because loose and corroded connections cause more trips than people expect. The screws that hold the wires onto the element and the thermostat can work loose over the years, and a loose connection arcs and heats up right at that point. Corrosion does the same thing. With the power off, look hard at every connection for browning, melted insulation, or green crud, and give the wires a gentle tug to feel for any that are loose. Tighten or remake the bad ones. And here is the line you do not cross. If you see any water on or near that wiring from a leaking tank or a dripping valve, shut the breaker off and call a pro. Water on live wiring is exactly the situation the breaker is trying to save you from. A few causes are not the heater at all, and you reach them once the heater itself tests good. The breaker can simply be worn out, they age, and after enough years or enough trips, the internal mechanism weakens and starts tripping below its rating or refuses to hold. You only land on this answer after the elements, thermostat, and wiring all check out clean. Replacing a breaker means working inside the panel so that one goes to a licensed electrician, and whatever you do, never solve a tripping breaker by putting in a bigger one. The breaker is sized to protect the wire in your wall, and a bigger breaker on the same wire lets that wire overheat instead of tripping, which is how you start a fire inside the wall. While we are off the heater, two install problems can cause this from day one. The breaker or the wire might be the wrong size because a standard electric tank needs a 30 amp double breaker on 10 gauge wire, and a mismatch there either nuisance trips or runs dangerously. The heater also needs its own dedicated circuit. If something else is sharing it, the combined load trips the breaker even when the heater is perfectly healthy. Both of those are a wiring job for an electrician rather than a part you swap. One more, and it is showing up more often on newer setups. A lot of water heaters now sit on a ground fault breaker, what gets stamped GFCI because the code started requiring it. A ground fault breaker trips on the tiniest leak of current to ground, so an element with a hairline crack that an old standard breaker would have shrugged off will trip this kind right away. The heat pump style water heaters can also nuisance trip a sensitive one from their electronics. Either way, a ground fault breaker that will not stay set is telling you real current is leaking somewhere, so you track that leak down rather than swapping in a plain breaker to make the warning go quiet. So where does that leave you? Testing elements and a thermostat with a meter, replacing an element or a thermostat, and flushing sediment are all reasonable jobs to do yourself with the power off. The panel, the breaker, any scorched wiring, water near the wiring, or a ground fault breaker that keeps tripping after you have replaced the obvious parts, those go to a licensed electrician because around 240 volts, the failure modes are shock and fire, and they are not worth guessing at. Most of the time, this comes down to a shorted heating element, a $20 part, and a 20-minute test, and the breaker that kept tripping was simply telling you which one. I have put an element socket, a multimeter, and a replacement element and thermostat in the description, so you can grab whatever your test points to and get the power back on the right way.